Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, we've got a real treat for you today. Here it is. Applications with Ken. Ken Jannotta is one of my all-time favorite coworkers at Horner. We've been working together for about 30 years. Ken's one of our engineering leaders, and we're going to have a great discussion with him today. Let's get right to it. Okay, so today we're talking with Ken Jannotta, our R&D manager at Horner. What are we going to talk about? Well, we're going to talk about some of the special applications that we've done over the past few years. And even though these aren't traditional industrial automation type applications, we're going to talk about what some of the benefits of doing those applications have been to the main Horner product line. So that should be a fun discussion. We're also going to talk about the technology that Ken is keeping his eye on, and also what's next for Horner automation products in the future. Before I bring Ken in here, I need to embarrass him a little bit with all his career accomplishments. So Ken is a Purdue grad. Okay, I won't hold that against him as a Kettering grad myself. And one thing that a lot of people don't know is that Ken created the very first Horner ladder logic editor in DOS. For those of you old enough to even know what DOS is, I believe it was in 1995 while he was still in college. So that's pretty awesome. We'll talk to Ken about that. And then after joining Horner, he turned a Windows application that had just kind of been started called WinLogix into the very first version of Cscape right around 1997. So that's pretty cool. And he's been, over the 30 years or so that he's been at Horner, he's been instrumental in helping steer Horner's technical direction, and he is currently Horner's chief technologist. Okay, let's bring him in now. How's it going, Ken?
Very good.
All right, we've got to start with that college project here. So tell us about that project where you were basically created the very first ladder logic editor for Horner back in the mid-90s.
Well, we were creating a conveyor controller, and it needed to be programmed. And so I, basically started from scratch creating it. I didn't know it wasn't possible, so I just put it together and got it working.
Pretty incredible. So that was for a very large post office project that we did. In the end, there were 35,000 controllers installed in the field that all use your ladder logic editor. Very cool.
Yes.
Okay, so then, so when did you actually graduate from Purdue?
December of 1996.
Okay, December. So sometime after that, you actually were full-time working for Horner finally, and then
Yes.
You basically were kind of the first Cscape engineer, weren't you?
Right. Yeah, we had somebody port the DOS version that I did to Windows. Then I kind of took it from there and worked on it for a number of years, about 10 years.
And okay, at the beginning, how many people were working on Cscape?
It was just me for most of the first 10 years. We later added some people, but
Yeah, absolutely. And currently, just in round numbers, about how many people are working on Cscape?
about 15.
About 15, exactly. So it's amazing how something that has such humble beginnings can just explode and be a big mouth to feed. Lots of features and the whole deal, right?
Yes.
All right. Now, one thing a lot of people don't know is that Ken's father, Ken Jannotta Sr., is one of my mentors. And here's a picture of me and Ken Sr. And Ken was a sales manager. He was a product manager. He was an executive in the automation industry over the years. For a number of years, he worked at Horner. I think we were his last stop in the automation train, and he was our sales and marketing manager. So definitely one of my mentors. How's your dad doing, Ken?
Oh, he's great.
Yeah, awesome. I did get it. That picture was taken about, maybe 3 years ago when I was going on one of my bike trips in the Carolinas. I stopped by in Charlottesville, Virginia to say hi to Ken. It was awesome to spend some time with your dad. All right, let's go ahead and get going.
Okay.
Okay, so the first kind of atypical application we're going to talk about is a large project that we've been working on for a number of years, working with a company that does mobile vehicle automation. So they don't actually build the mobile vehicles, they actually create all the automation pieces that other companies use to build a mobile vehicle, such as emergency vehicles and that sort of thing. So, Ken, let's talk a little bit about some of the requirements of their application. I've got them kind of listed there in the screen.
Sure. Well, I think part of it is inside a vehicle, they will break up the control. There may be 20 different modules that control lights and pumps, different displays. You've got displays in the cab, displays in the back, displays on the side. So that distributed control that we've done since the conveyor controller worked really well in the application. That's something that drew them to our technology.
Great. And then also distributed touchscreens. So I guess that's just to control all the different peripherals all over the vehicle.
Right. Just to ease the wiring, you could have a full controller at each location, but there was a desire to have a remote display so they could have different displays around and then have a central control unit that was stored away more safely in the vehicle.
Yeah, that makes a lot of sense. Then, of course, because of the fact it's a mobile application, all the electronics had to be packaged mobily, right, or in a mobile appropriate form factor. So a lot of I think if I remember correctly, the result is a mixture of circuitry, some technology from our customer, some technology from Horner, packaged specifically for the mobile market, right? That's kind of how they did it.
Exactly. Yeah, we were able to kind of share technology, learn from each other, and some of the stuff we developed together. We didn't know how we were going to do some of those early on and kind of went through that.
So effectively, all their CPUs are programmed with a special version of Seascape for all intents and purposes.
Exactly. Yeah,
Oh,
it looks very similar to Seascape 10.
okay, very cool. All right, so let's now talk about some of the technology transfer, if you will, some of the benefit that our standard customers who aren't necessarily in the mobile market will see from this relationship we've established. So we've got some outdoor viewable screens coming for the XL7 Prime and the Canvas 7D here in the next few months. Talk about that a little bit.
Well, we've always had kind of brighter than typical screens in our products, but we got introduced to some new suppliers that provide automotive level screens. So they're extremely high brightness, high contrast, very rugged from a vibration and shock standpoint, 10 or 20 times what you would typically see in industrial products, and then wide temperature range. So on our older products, we would have to add a heater if we wanted to operate in Minnesota or Canada. These products are designed to go from like minus 40 to 60, 70, 80 degrees C out of the factory.
Very cool. Really, very cool. Awesome. So you'll hear more customers from us over the next couple months as we get ready to launch these versions, these special high bright outdoor versions of the XL7 Prime and the Canvas 7D. And before we go any further, even though these products are almost ready, I do want to give a little bit of a disclaimer. We're going to talk about some things that are further out and some things that frankly may never happen, but are options that we could take to the market if the market demand, is there. So keep that in mind as we review some of those things, viewers. Let's go on to the next one. Okay, so the next one, this is very cool. Now, this is how kind of the way, technology-wise, that they distribute touchscreens throughout the vehicle, right? So tell us about this.
Sure. I mean, early on, we looked at using HDMI or DisplayPort to send the display signals. And then we found, for almost 20 years, a lot of the automotive manufacturers have used a special interface. There's a couple different variations of it. But basically, in an automotive application, you want to limit how many wires you run to reduce the weight and complexity and cost. So we were able to latch onto one of these technologies and then provide high resolution display graphics that are basically instantaneous. There's no delay in sending the signal out to the display. It powers it with the same cable, and then it sends the touchscreen information back to the controller. So you've just got one 4-pin cable to handle all the power and data both directions.
Yeah, that anybody who's watched this channel lately has probably seen a preview of this, or if you've come to our trade shows, you've seen a preview of this. We'll be launching this summer, and literally, it's like you ripped the screen off the front of an all-in-one controller OCS, and you put it in a chassis, ran one cable to it, remotely mounted it somewhere within 15 meters or so of the controller, and now you've still got an all-in-one, but you've got a remote screen to go with it. Very cool. And our partner has a couple of models that we're going to be offering that are extremely rugged. I think they have a 7-inch and a 10-inch, right?
Right. And a 12-inch is coming.
Okay, great.
Yeah, those are really wide temperature range, minus 40 to 85 C, and rugged for kind of those vehicle type applications.
Yeah, very cool. And you could use them in other applications as well. And at Horner, we've got some HMI Connect models of our own that we'll also be building and manufacturing in Indianapolis that are more traditional in their construction and the way they mount and control enclosures. So this is definitely a technology that we're able to acquire from this relationship. Very, very cool. I think it's going to be a game changer in industrial automation as it comes to Horner.
Yes.
Okay, let's get back to the distributed control nature of this application. So you've got a vehicle, you potentially have a bunch of different nodes, if you will, that are doing control. They're not just I/O in every case. They often have logic there. But you now have all these different, let's call them PLCs, because people will think that way. We've got a bunch of different PLCs that all need to communicate with each other. And to do that, we jointly ventured with this company something called network variables. How does that work?
Well, since the conveyor controller, we've supported our C-scan protocol, which allows broadcasting variables out into the network, and any device can use that data that's sent out. That was done for the original conveyor controller project. The interface was kind of more typical industrial, where you had, registers that you had to put out and ones that you received, and it requires some setup. But the goal here was to allow somebody that was developing a fire truck or ambulance or other type of device just to be able to set up a variable and just kind of have it magically transmit to all the other devices that are on the same network. So it happens over CAN or Ethernet, where we synchronize all that data. And any device on the network can read or write the data, and it just automatically synchronizes between them. So that's what we call network variables as our new technology that will be rolling out to OCS products in the future.
Yeah, very cool. So any application where you do have multiple OCSs in an environment, it's very, very powerful. And if I remember correctly, you can kind of start with a common set of variables using an XML file or something like that.
Yes, yeah. In their case, they've got, a couple thousand variables that are predefined. And so it'll maybe the left front spotlight. And so all the devices can see, is that on or off, or they can turn it on or off. So if you're inside the cab, you can assign that to a button and just say front left spotlight on, and whatever controller is receiving that can receive that information and then automatically turn that light on its output.
Yeah, very cool. And on the next page here, I think I have a peek here at some of the configuration of these network variables where you can basically determine, are they bit type, are they, words or integers or floating point, are they change of state, are they changing, periodically, all that sort of good stuff. So pretty awesome stuff. I can't wait for that to come to OCS. Very cool. All right. The other thing that this definitely fits in the category of products that could come to the market, okay? Because we have a partnership with our, mobile development partner, and they've developed all this hardware, which is ruggedized I/O for the mobile market with Horner logic engines embedded inside it in a lot of cases. We have an agreement with them where we could potentially offer these products to the industrial market or to the mobile market in certain cases. This is pretty intriguing as one of the possibilities for the future. So before we dive into it any deeper, what are those connectors you see on the front there? Are those special type automotive connectors?
They are. They're Deutsch brand connectors. So TE owns the company that makes those, and those are very heavily used in the more rugged vehicle applications. So fire trucks, ambulances, snow plows, construction equipment all use these type of connectors.
Right, very rugged, not the type of connectors we're used to seeing in the industrial market, but for those who work in the mobile space, I think they're probably very familiar. One thing that's really kind of cool here is you can't tell from a slide or a picture, but that one on the left, it is a horse. I mean, it's like an extruded aluminum frame, right?
Yes.
Okay, and the DC ground connection is basically that aluminum chassis, right?
Right. And then that bolt on the top is a 200 amp power input to be able to provide all the outputs, power.
Which is one of the big differences between outputs in a mobile application versus a factory application. What is the power of some of those DC outputs there?
They range from like 3 to 20 amps per channel.
3 to 20 amps per channel. That just cracks me up every time. And a lot of them are PWM style, right?
Right. There's high speed inputs and outputs. We basically took our micro control engine and kind of reformatted it for this application. So a lot of those same applications that we can do on that, we can kind of do internally with this.
Right, exactly. So this is some pretty cool stuff. And I think on the right there, that's like an IO block for the most part. Is that what we're looking at there? A smaller version.
Yeah, it's smaller, I think that's only 100 amps kind of thing.
Has a smaller bolt on it, but it's still got a it's still got a like a micro OCS logic engine embedded in it, right?
Exactly, yes.
Very cool. That's definitely distributed control for sure. All right, good stuff. Okay, so the next application we're going to talk about, and we're going to, again, we're trying to be very, we're fair to all our partners and everything. We're just talking in general terms, not giving away any secrets or anything like that. For the next application, we're going to talk about an application involving autonomous control. So this is with another great partner. Ken, why don't you talk about the requirements for this particular project?
We'll start with like the previous one. It needed to be rugged enclosure, so having waterproof, shock-resistant enclosures were key in this application. The other thing, just like in the emergency vehicles, we are powered by 12-volt DC, so with a battery. The other challenge is when those big diesel engines start, the voltage drops quite a bit. So we had to deal with that in this application.
Mm-hmm. Yeah, and again, this is indoor or outdoor applications. So
Right.
yeah, like you said, ruggedness there. So that means there was also cellular and GPS involved in this case as well, right?
Right. Yeah. With cellular communicating, getting correction data for GPS. And then we have both high accuracy and regular GPS in the various applications.
Oh, wow, pretty cool. Okay, so let's talk about a little bit about some of the technology we've been able to harvest from this particular relationship. First of all, we were able to take advantage of what we learned from that tough 12-volt environment to improve the power circuitry in some of our newest products.
Yeah, we always strive to have a wider voltage range product than a lot of our competitors. But when you're on a 12-volt battery, you have to do things a little different. You need to be able to handle the starting voltage. So in some cases, you need to run at very low voltages or no voltage for a very short period of time. And then as the different loads on an engine shift, you can have big surges that come in. So improving the front end protection of our products was important for those vehicle applications. So we're able to take some of that technology and some of the knowledge and kind of scale it to some of our new products. We don't need the full level of protection and voltage, wide range voltage, but some of that technology we were able to introduce into, for example, the OCS-IO products or some of our new OCS products.
Yeah, and in there have been quite a few applications over the years that have been run with OCSs at 12 volts. So that's pretty important. So yeah, so definitely a benefit for sure. Another area is that we're working on. This is one of those products that we're just starting to work on, and that is an add-on cellular modem because of, in part at least, because some of the experience we gained from this application on the cellular side.
Yes, yeah. In the past, we've done some work with cellular, and it's an evolving technology. So staying up to date, especially in an industrial product where you want it to be active for 20 years, that's always a challenge. So we're looking at a more modular approach, but we've gained a lot of knowledge on kind of some of the more modern cellular capabilities, and we're looking at incorporating that into future controllers.
Yeah, and what I've shown here on the screen drawing-wise, that's just what our current Wi-Fi adapter looks like. We haven't finished the packaging yet for this yet, correct?
Correct. Yeah, we're still looking at some different options for packaging that.
Right, and then how do you anticipate it'll connect to an OCS network-wise?
We're looking at options that are both Ethernet and USB. So depending on the OCS you're trying to connect to and the features, we may have one or both options.
Okay, very cool. Awesome. So keep your eye out for that in the future.
Yes.
Okay, this is very cool. So whereas in the application with the emergency vehicle guys, they separated their screens from their controllers, in this case, it looks like we have a fully integrated unit there. What are we looking at?
It's really kind of the heart of a Canvas 7 product. It's got the high brightness, wide temperature display that we talked about earlier. It uses the Deutsch industrial connectors, and we've kind of limited the I/O. So it's got just enough I/O really for a mobile application, but there's a lot of industrial applications it may fit in. So it's got a USB port to look at a backup camera or a forward camera, but you can also add Ethernet or Wi-Fi, things like that. It's got an audio output for electric vehicles. So this is used both on gas and electric vehicles. The electric vehicles have to produce certain noises when you're moving forward and backwards. So it's able to do that or sending alerts. And then it's got two CAN ports to talk to various devices. So either remote I/O or engine controllers or things like that.
Yeah, very cool. Because CAN is still very much the kind of the standardized network on in the automotive and the mobile markets for sure. So
Yep.
so very cool. And that if I remember correctly, that small circle on the back of the unit to the left, that's some sort of a vent, right?
Yeah, it's to equalize the pressure because as you have temperature changes and pressure changes, you don't want to pressurize or create a vacuum in your enclosure. So that vent keeps it equal. It's an IP69 enclosure. So it needs to be able to withstand, high pressure water, temperature, things like that.
Very cool. So again, this is another one of these products that we don't have a specific release date for, but it is still kind of not that far away, at least from a technical standpoint.
Correct. Yeah.
All right, very cool. All right, one thing I was going to ask you about, and I'm not aware of any firm plans now, but anything we can learn from the GPS experience we had with that project?
Well, we've used GPS for almost 25 years at Horner. We started using it for high accuracy timestamps, and OCSs have supported the GPS kind of standard GPS protocol for 25 years.
Right.
So we've gone down two different paths. There's kind of a low cost. So the module you see on the left is one that we use. It's an integrated antenna, low cost, good, but not centimeter level accuracy. And so we've incorporated that into some special products. And then the one on the right is a variation of high accuracy. So we can get, up to centimeter level accuracy for that autonomous or driver assistance functions that we've integrated into some of those products.
Yeah, so nothing firm yet on the GPS side. Just be aware that if you do need GPS level support, we already have it. A couple different ways you can do that. An easy way you can do it, Banner has a GPS puck that talks Modbus that you can connect directly to any of our products. And then Garmin also has a device that talks NMEA, which is one of the standardized protocols that's built right into every OCS we produce today. That's a marine protocol for getting GPS data, and that's currently supported as well. So you've got some options today, just not with that centimeter level accuracy.
Right.
Okay, very good. Okay, kind of to wrap up here, let's just go into some general discussions on some technologies and things. So over the years, we've gotten quite a few requests for additional Ethernet protocols above and beyond what we already support. Where are we headed with expanding our industrial Ethernet capabilities?
Well, we're creating a whole pipeline of new protocols. So Ethernet IP, EtherCAT, Profinet. We're planning on supporting all those, looking at how they best integrate into the OCS ecosystem. But those have already started.
Yeah, and to be clear, with Ethernet IP, we support everything today except scanner, which is the ability to direct or control an Ethernet IP network. And that's what we'll be adding here in the future. Very cool. One thing, I did some research recently on two-wire Ethernet, and you kind of helped direct me that direction. So what's going on with two-wire Ethernet? What is it, and how might it apply in the automation space?
Well, it started on the vehicle front again. So again, to reduce the number of wires and the complexity in vehicles, this was kind of developed. So there's a whole series of new chipsets, connectors, cables that are being developed around this. Some of the lower speed versions allow you to daisy chain like CAN, and the higher speed versions allow power to be passed. So in vehicle space, it's taken off, especially where you need higher speed video and data for some of the infotainment and driver assistance functions. On the industrial side, it's started kind of in the intrinsic safety because you only have two wires. It's easier to protect. So in that area, we're seeing some growth. The general industrial environment hasn't really latched onto it. It requires special cables, and those have pros and cons, and just having people switch over to that may take a while.
Yeah, exactly. But it's something to keep your eye on for sure. So,
Absolutely.
pretty cool technology there. Just again, standard Ethernet is two pair, where you have one pair for transmitting and the other pair to receive. With two wire Ethernet, you have one pair. So, again, like Ken said, half the conductors there. What's going on in the wireless world? I have a couple specific questions. We hear a lot about Bluetooth, right? And we all use it for our desktop stuff and for music and things like that. Why hasn't Bluetooth caught on in the industrial space other than for things like configuration tools?
I think there's a couple issues with it. Some of the earlier versions of Bluetooth did have some security issues where, if it's just your headphones connecting, it's not as important to have the security level. But if you're programming or working with industrial controls, you need that, higher tier of security. And then just the performance. The previous versions of Bluetooth were quite slow. They were designed for compressed audio or keyboards, mice,
Right.
and they didn't really fit into the industrial applications.
So, do you see Bluetooth kind of finding an additional place in the industrial market in the future?
I do. There's mesh versions of it that allow sensors to be collected and you can kind of do repeating. The speed and security have both improved in Bluetooth. So it's starting to compete with some of the older versions of Wi-Fi. As Wi-Fi evolves, it becomes more expensive, but higher speed. So it's kind of filling in that gap where Wi-Fi used to fit.
Yeah, that makes sense. Also, I know we've done some proof of concept developments over a wireless technology called LoRa. What is LoRa?
LoRa is a lower frequency radio that's relatively low power but very long range. It's designed to send small amounts of data. So things like water meters, where you're going to transmit from a water meter up to a water tower, 10 miles away, using a AA battery. It was really developed for that type of technology, and it's something we've looked at for lighting or sensors, gathering data like that back into an OCS.
Right. Yeah. So we don't have any specific plans at this stage for LoRa other than the proof of concepts we've done, but it'll be interesting to kind of follow that technology and see where it goes. What about we've been asked for capacitive touchscreens, larger touchscreens, kind of what's going on with that?
So capacitive touchscreens, we're starting to integrate some of those. So you'll see, some of those partner products that we talked about, the HMI Connect or the Nomad products are capacitive touchscreens. One of the big challenges with capacitive touch is dealing with water and ice and gloves. We wanted to be 100% sure that we were going to, be able to handle those environments when we switched over. So we're working with some suppliers that have proven that they can handle those types of environments that our industrial products go into.
All right. And then what do you see more and more cameras are being, integrated in the automotive world, obviously.
Sure.
And I think we're starting to see some of that in the vision and the robotics areas of automation. Where do you see camera integration going in the future?
Well, we're looking at a couple different areas. So one is having integrated cameras to do face recognition, barcode scanning, gesture recognition, things like that. And then bringing in cameras over Ethernet or other interfaces. In the past, we've had products that bring in cameras over, analog or USB. So looking at some of those higher speed digital interfaces, I think is an important migration in that technology. And then we're looking at, once we get that camera data in, what else can we do with it to help the customer?
Right. And that kind of leads into that next area, and that is artificial intelligence. What's Horner working on for artificial intelligence?
There's a lot of different areas. So one is that, vision system. So, doing face recognition or some simple, we're not looking to replace vision cameras, but kind of augment it or provide some simple applications. But we're looking at, artificial intelligence in control loops, abnormality detection, several different areas in that.
Right, and it's certainly an area where, and you'll start to see us promote this a little bit more in the future, but where we can partner with some of our customers who are looking to do a specific AI project. We'll have the ability in the future to be able to partner with them for a specific project. I know we've got some, some pilot programs going now. I know we have at least one pilot program in temperature control, if I remember correctly, in one of our facilities. Is that correct?
That's right.
Yeah.
And Horner's always been strong at gathering data. I mean, some of our products 15 years ago were great at logging and recording data. So that's a really key part of artificial intelligence is gathering the data that you can use for training or for those types of detection processes that either we do on the product or in a cloud.
Exactly. And we've got OCS 360, easiest
Right.
way you can possibly get to gather and record data from an OCS in the field. And in the future, I've heard some rumblings that there might even be some artificial intelligence or at least some neural engines in some high-end future products that we're looking at.
Absolutely. Yes.
Yeah, awesome. Okay, well, Ken, I really appreciate you joining us today. It's been a lot of fun having this discussion with you, and best of luck in the future. And of course, we work together, so I'll probably see you
Yes.
tomorrow.
Absolutely.
All
Yeah.
right.
Thanks for having me.
All right, take care, Ken.
Okay. Okay.
That does it for today's content. I hope you enjoyed that conversation with Ken. I know I sure did. Hey, don't forget to get involved in our case study program. If you agree to fill out all the appropriate paperwork and take some pictures and tell us about one of your recent applications with an XL Prime, a Canvas, or OCSIO, then if everything goes as it should, you'll get a free controller out of the deal. That's a pretty good program. Contact our marketing department at the email on the screen. Training is still available. We've got a class that's going on in June for the advanced folks and a couple of courses in the fourth quarter. So sign up for those today online. Lots of opportunities to see us at trade shows yet this summer and into the fall in the Midwest and in the South. If you missed us in Detroit a couple weeks ago, we'd love to see you at one of these locations. All right, lots of ways to interact with Horner online at hornerautomation.com, on our YouTube channel, or on LinkedIn. Okay, check our website for the June topics. The one thing you can be sure of is that every Tuesday in June, we will have a topic for you with good information regarding industrial automation, regarding Horner Automation and their products in particular. We look forward to seeing you on Tuesdays in June at 2 o'clock Eastern. If you haven't subscribed to our channel, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live and every time we post a new video. All right. So until next week, let's all get out there and do some good.